Silent everyone. Today we will start or we will discuss the sharpness of resonance. Sharpness of resonance. So, if we draw a curve taking P along x-axis and Ek by Ek max, where Ek is the kinetic energy of the particle under force vibration. Okay, Ek is the kinetic energy of the particle under force vibration, and Ek max is the maximum kinetic energy. Okay, then we get a curve like this. So which one is the short part? Which one is the short part? The orange one? Orange one is the short part. Okay, how do we know that? Okay, now we have to find out the mathematical proof that the orange one is the sharp part. So how will we do it? Here, Ek by Ek max is half. And here it is omega naught. What is omega naught? Omega naught is the natural frequency. So when we know that when P equals to omega naught, then the velocity is maximum. We have already found out the velocity resonance. So in the velocity resonance, from velocity resonance we know that at P equals to omega naught, the velocity is maximum. So if the velocity is maximum, that means kinetic energy is maximum. So Ek becomes Ek max. So Ek max by Ek max equals to what? So at P equals to omega naught, it is 1. Okay. Now at half, when the Ek by Ek max become half, we say this is P1, this is P2. So at P1 and P2, the Ek by Ek max become half. Okay. So draw the figure. Now the definition. Definition of sharpness of resonance. The sharpness of velocity resonance. The sharpness of velocity resonance is defined as the sharpness of velocity resonance is defined as the rate of fall in velocity amplitude. The rate of fall of velocity amplitude. The rate of fall of velocity amplitude with the change of the frequency of the applied periodic force, with the change of the frequency of the applied periodic force on each side of resonant frequency, of each side of resonant frequency, on each side of the resonant frequency, side, SID, side of the resonant frequency. So what is the meaning of that? That P equals to omega naught, we get the resonance. Okay? At P equals to omega naught, we get the resonance. So omega naught here is called the resonance frequency. So if we go from the resonance frequency from either side, okay, either left or right, then how the substance, that is the Ek by Ek max decreases. Okay, how the Ek by Ek max decreases. That is known as the sharpness of resonance. So you can see that the orange one is more sharper. Why? Because it is more rapidly decreases as we go from omega naught to P1 or P2 direction. Okay? This is P1 and this is P2. So if we come here, this is P1 dash, this is P2 dash. Okay? So this is the P2 dash minus P1 dash is less than the P2 minus P1. So why? The inner one is the more sharper than the outer one. Okay? So now we have to find it, or we have to find the mathematics. Okay? Mathematically now we have to prove it. Which one is sharper? From the figure, at P equals to omega naught, from the figure at P equals to omega naught, Ek by Ek max is maximum. At P equals to omega naught, Ek by Ek max is maximum. Okay? That is 1. Now, when omega naught takes the value P1 or P2, when omega naught takes the value P1 or P2, then Ek by Ek max equals to half. Then Ek by Ek max equals to half. Ek by Ek max equals to half. When omega naught equals to P1 or P2. We know the kinetic energy. Ek equals to half mv naught square. We know the kinetic energy Ek equals to half mv naught square. Why we take v naught instead of v? V naught is the velocity amplitude. Sin omega t minus sin pt minus delta. V naught taking, this is the common amplitude of the velocity. So this will change only, amplitude will change of the velocity. So I take V naught. We know velocity amplitude V naught equals to F by P by root over 4 k square P square plus omega naught square plus P square A whole square minus omega naught square minus P square A whole square. Okay, that is the V naught, the amplitude of the velocity. Now if we take P square common, so this is equals to F by P. If you take P square common, outside the root over it becomes P. Here you have root over 4k square plus omega naught common and there is one P only. P common is P square. এই যে এখানে স্কয়ার আছে তাহলে একটা P নিয়ে স্কয়ার হয়ে গেল। Okay? Now P cancel. Now we take omega naught square common. Okay? Now we take omega naught square common. Then what's happened now? So V naught equals to F by root over 4k square plus omega naught square, omega naught by P minus P by omega naught a whole square. Okay? এখান থেকে এখানে নিয়ে নাও ওমেগা নট এখানে স্কয়ার আছে সো ইট বিকাম ওমেগা নট স্কয়ার এখানে গেলে নিচে একটা ওমেগা নট চলে ওকে সো দিস ইজ ইকুয়ালস টু f by root over 4k square plus omega naught square into del square. Equation 1, equation 2. Where del equals to omega naught by P minus P by omega naught. Equation number 3. Where del equals to omega naught by P minus P by omega naught. That is the difference. So this is equals to what is F? F equals something like F naught by M root over 4k square plus omega naught square del square. It is equation 2 बोलता है. F naught by M 4k square plus omega naught square del square. Follow? So we get the V naught. Now put it in equation 1. Therefore, right? Therefore, the kinetic energy becomes. From equation 1. Therefore, the kinetic energy becomes Ek equals to half m V naught square. V naught square means F naught square by m square into 4k square plus omega naught square del square. Okay. Now at m cancel. So this is equals to 1 by 2m F naught square by 4k square plus omega naught square del square. This is the Ek, kinetic energy. Equation number 4. velocity is maximum when p equals to omega naught. At p equals to omega naught, we get the velocity resonance. That is the velocity is maximum. So at p equals to omega naught, the tail becomes 0. Okay. At p equals to omega naught, tail becomes 0. That means at the time kinetic energy is maximum. At p equals to omega naught, tail equals to 0. See, if tail equals to 0, this is 0. So denominator becomes the minimum 4k square only. Okay. So ek becomes maximum. When p equals to omega naught, then del equals to omega naught by p minus p by omega naught equals to 0. When p equals to omega naught, del equals to omega naught by p minus p by omega naught equals to 0. Okay? Therefore, Ek max, maximum kinetic energy, therefore maximum kinetic energy equals to 1 by 2m f naught square by 4k square. Equation 5. Okay? At p equals to omega naught, then equals to 0. And we know that at p equals to omega naught, there is a velocity resonance. What is velocity resonance? When the velocity amplitude becomes maximum. So if the velocity amplitude becomes maximum, that means the kinetic energy is also maximum. Okay? Kinetic energy is also maximum. Now, what is Ek by Ek max? The sharpness of resonance, write down a quantitative definition of sharpness of resonance. The sharpness of resonance quantitatively defined as the sharpness of resonance quantitatively 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 defined as reciprocal of magnitude of del at which Ek by Ek max equals to half. Okay? So magnitude of reciprocal of del at which Ek by Ek max equals to half. That means how rapidly the energy decreases if we go from omega naught to Q1 or P2. Okay? How rapidly it is decreases. Ek by Ek max equals to half. This is equal to 6. Now what is Ek by Ek max? Ek by Ek max equals to all they cancel, then 4k square by this one, or Ek by Ek max equals to half, or 4k square by 4k square plus omega naught square del square equals to half. Or 4k square plus omega naught square del square equals to 8k square. Or omega naught square del square equals to 4k square. Or del equals to plus minus 2k by omega naught. Equation number 7. Del equals to plus minus 2k by omega naught. Del equals to, so at del equals to plus minus 2k by omega naught, ek by ek max equals to half. Okay, and as per the definition, quantitative definition, reciprocal of del at which ek by ek max equals to half. Okay, therefore the sharpness of resonance is given by, therefore the sharpness of resonance is given by therefore the sharpness of resonance is given by a star equals to 1 by reciprocal of del বলেছিলাম sharpness is the 1 by reciprocal of mod of del, that is SR equals to 1 by del. Why mod? Because there is the plus minus, so only we have to take the plus side. Okay, or SR equals to omega naught by 2k. SR equals to omega naught by 2k. Equation number 8. So this is the sharpness of resonance. Okay, again you can see that this is the quality factor for the damped vibration. E equals to equation B, omega naught by 2k. In case of damped vibration, the quality factor was omega naught by 2k. So in forced vibration, which one is the sharpness of resonance? That is the quality factor in case of damped vibration. Also, in forced vibration, this is also called the quality factor. The sharpness of resonance is also called quality factor. Okay? Now we have to find out the value of 2k in terms of P2 and P1. We have to find out the value of 2k in terms of P2 and P1. Take equation down there. Equation. This is 6.1 for the. This one, omega naught square del square equals to 4 del square. From equation 6.1 we get omega naught square del square equals to 4k square, or omega naught square omega naught by p minus p by omega naught a whole square equals to 4k square. Now take the root over, or omega naught into omega naught by p minus p by omega naught equals to plus minus 2k. Multiply by omega naught, or omega naught square by p minus p equals to plus minus 2k. Or omega naught square minus p square equals to plus minus 2kp. P is the LCM. Or p square plus minus 2kp minus omega naught square equals to 0. Equation number 9. I don't know. Okay. Now there is two equations. There is two equations. One is p square plus 2kp minus omega naught square equals to 0. Equation 10, and p square minus 2kp minus omega naught square equals to 0. Equation 11. Okay. Now how we solve it? Follow. What's happened? Now how we solve these two equations 10 and 11? 10 minus 11, there are two equations. One is 10, another is 11. Then how we'll solve it? If then okay. So if we solve using Pythagoras, then what happened? When you solve this one, then what is P? We say this is P1. From equation 10. From equation 10. P1 equals to what হবে? Hello. From equation 10 using Pythagoras, what is the value of P?
Minus 2k.
Minus 2k plus minus root over 4k square minus 4
p omega naught.
that is plus हो जाएगा 4 3 क्या है
p sir p omega
और
minus 4 ac का सर minus 4 p omega p omega सेम है
4 PAC एक तो देखो 1
ये वेरी होना चाहिए
by 2. Okay, so this is minus k plus minus root over k square plus omega naught square. So here you can see that there is two values, plus minus. So what value will we take? Plus. Why? देखो k square plus omega naught square is always greater than k. This is always greater than k. So if you take the minus sign, it becomes minus. But we know that P is the frequency of the applied force, which will be not minus. Right? The frequency is not negative anytime. So we don't take the minus sign. Okay? Therefore, P1 equals to minus k plus root over k square plus omega naught square. Similarly, from equation 11, what is the value of P2? From equation 11, we get P2 equals to plus 4k, right? Minus 2k, so it is 4k plus minus root over 4k square plus 4 omega naught square by 2. So this is equals to again again k plus minus root over k square plus omega naught square. Okay, or P2 equals to k plus root over k square plus omega naught square. Equation 13, equation 14. Okay, again, therefore, if this is minus, then this is greater than k, then P become again negative, which is not possible. Okay? P, that is the frequency of the applied kinetic force, which is never negative. Frequency is never negative. So P1, P2, we get P1 and P2. Any problem? Equation? So, 11, 12, 13. 12, 13. Now what is P2 minus P1? Therefore, P2 minus P1 equals to 2k. P2 minus P1 equals to 2k. Therefore, the sharpness of resonance, SR equals to omega naught by 2k, or SR equals to omega naught by P2 minus P1. Therefore, the sharpness of resonance SR equals to omega naught by 2k equals to omega naught by P2 minus P1. Okay, so from here you can also see that if 2k, what is 2k? 2k is the damping force per unit velocity per unit mass. That is the damping force. So we know that as the damping force decreases, the quality of the vibration increases. Here also you can see that as the damping force decreases, the sharpness of resonance also increases. Okay? So what is now P2 minus P1? P2 minus P1, for the white one, P2 minus P1 is larger than the P2 dash minus P1 dash. From the figure you can see that P2 minus P1 is larger than the P2 dash minus P1 dash. But if P2 minus P1 is less, then sharpness is high. So P2 dash minus P1 dash is less. So why the sharpness of the orange one is high? That is the sharper than the white one. P2 minus P1 যত ছোট হবে, sharpness তত বেশি হবে. Okay, now what is P2 minus P1? P2 minus P1 is called bandwidth. P2 minus P1 is bandwidth. It's called bandwidth. And the band BAND width, WIDTH, bandwidth. Okay. The quantity omega naught by P2 minus P1, the quantity omega naught by P2 minus P1, the quantity omega naught by P2 minus P1 is called quality factor Q, capital Q, is called quality factor Q. Is called quality factor Q. Therefore, Q to SR equals to omega naught by P2 minus P1. Okay, so this is the Pauling factor for the force vibration. So from here, what is the use of this one? Sharpness of resonance. All of you use this one. All of that. In FM radio, what's happened? What you are doing? Tuning the frequency. Right? In case of FM, we are tuning the frequency. Why we tuning the frequency? So that we get the resonance. At P equals to omega naught, we get the sharp sound. That is the sharpness of resonance. Okay, so when P equals to omega naught, then what happens? When P equals to omega naught, then we get the sharp sound. But if we go from omega naught to either P2 or P1, that is the higher frequency or the lower frequency, if we go from omega naught to either P2 or P1 side, then what happens? We get the sharpness, that is the frequency, sharpness, that is the resonance frequency with some noise. If we get the sound, but with some noise. And that is called the bandwidth. Okay, that is the bandwidth. And this is the sharpness of resonance. So this is the force vibration. In the next class, we will do the LCR circuit. Okay, LCR circuit, and then the oscillation will be completed. In the after visualization, we will start optics. Okay.